Hey everyone, welcome to another KeyMaster episode. I'm Sven Rajala, and today I've got my good friend.
Tomas Gustavsson.
And now we're going to look at what does it mean to be the post-quantum ready. And what I mean from that is we went to the post-quantum crypto event that the PKIC had in Austin last month. Great event, lots of good speakers. Kudos to Paul and Albert for such a great event. And we heard all these great presentations of speakers. And now I'm kind of thinking, okay, we've talked about discovery and we're getting closer to wanting to know what it means to be post-quantum ready to start actually doing a true transition. And I mean, we've talked about C-BOM. There's a lot of C-BOM conversation, right?
Yeah, we even had there was a talk about C-BOM at the conference, and I know you had one here at KeyMasters about C-BOM. So I guess it can be a great tool because theoretically, if you have all your ducks lined up in a row, is that the right phrase?
Yeah, your ducks in a row, yeah.
Yeah, ducks in a row with your C-BOMs, then when your C-BOMs don't have any RSA or EC or Diffie-Hellman in it anymore, but only MLDSA and MLCAM, then you're done, right?
Would it ever be that simple though? Seriously. I mean, that's like a perfect dream world, but I mean, other things we could do, right? What else could we do? Such as like, okay, let's look at networking, right? What would I need to be at to be able to truly move to post-quantum from a networking perspective?
Yeah,
it's the protocol level like that.
From a post-quantum perspective, it's to protect against the harvest now, decrypt later threat, which is probably affects every organization. You need to secure your TLS communication with post-quantum algorithms. And that's something that I don't think everyone has realized is that it involves moving everything to TLS 103 first.
Right, so that means all my web servers, all my clients, all need to support TLS 1.3 before we could actually do something about true migration to full PQC.
Yeah, because TLS 1.2 will not be updated with post-quantum algorithms. It will only be TLS 1.3, at least the way it looks right now. So, and I mean, I think large organizations have pretty big projects moving from TLS 1.2 to TLS 1.3. So that's a project in itself, which is a prerequisite.
Wow. So, I mean, that's seems like it's not a heavy lift, but it's a heavy lift.
Or yeah, depending on who you are, maybe you're already done and it's easy. But I think for many organizations, it is a heavier lift than you initially think when you just think about.
Well, I mean, yeah, you've got legacy stuff out there, and it's got to be updated to support TLS 1.3 then.
I mean, and another use case, of course, the CNSA 2.0 always put a big emphasis on software updates, over-the-air updates, firmware updates to protect those with, or to be quantum safe in order to update your stuff out there. So that should be a big thing for manufacturers and, anyone who develops firmware, which is sent out somewhere.
That's going to be an interesting one too on how to handle that, especially for constrained devices, perhaps, or some of the less compute. Well, the constrained like that, that's going to be interesting in itself. Thinking about it.
Yeah, it definitely needs careful planning and implementation, phase-wise implementation by these organizations, and they will have to start thinking about it.
So there could be a big hardware refresh coming for stuff at that point because of having to support that.
Yeah, or planning the phase out of old hardware which is incapable, maybe it's even incapable of being remotely updated, right?
Wow. And then I guess there's the secure boot perspective too, because that'll have to be PQC moving along from OTA to that side of it. That's going to be coming.
Yeah. As you say, when starting to think of it, you look at firmware updates, but once you start digging deeper, which was also some presentation at the PQC conference, then you start looking at the whole life cycle of these devices, which then includes secure boot and everything that comes with it. The device has to do TLS, the device does secure boot, it does secure firmware updates. So, each device have a lot of different aspects of migration.
Yeah, it's not one size fits all or anything like that. It's a lot of dependencies.
Yeah.
And then thinking about that even further, what about crypto and not PQ crypto or, cryptography? I'm talking about like,
ledgers.
Bitcoin crypto or Ether, exactly. Whatever the other ones are. Monero, I think is another one.
Yeah.
What are they going to do?
And has to today, most of them use elliptic curve signatures, right? If you have a wallet for your
your
for
currency,
your blockchain, whatever it is, then typically there's an elliptic curve key there which signs transactions, and it has to change. And what that involves, I guess, well, I'm not a blockchain expert in any way, but there's migration ways for different blockchains. I think they have different methods, but it can involve a fork of the chain.
That'd be wild. Would they? Yeah, thinking about that, do they make a new branch, I guess, off of that? Because you can't really take all the signatures from a previous trunk and re-sign that all. You'd have to just kind of fork off and start a new branch that's all PQC, I would think.
Yeah, and all wallets have to be updated, of course, generate new keys and start using those instead of the old ones.
That's going to be a very interesting world to watch how that moves to post-quantum then.
I think when you start digging deep into, planning your quantum readiness, you find all these use cases which are not obvious to start with, because maybe it's operated by someone else, or it's just a small part of things like your OAuth tokens as well.
Oh, there's another big world. Everybody loves some OAuth these days.
Yeah. Of course, OAuth have kind of key rollover, signing key rollover, which, the big providers, they roll over keys occasionally, but all clients and servers have to handle the new algorithms.
And now the big payload of the nice tiny elliptic curve, or some of the RSA ones, which are bigger, but then go into a post-quantum one. Now that's going to be a lot more data.
Yeah.
With the signatures of the JSON tokens or your JWT like that. That's going to be interesting from the OAuth perspective side of watching that move to post-quantum.
Exactly. Or cookies will grow a couple of kilobytes. And of course, when we talked about blockchains as well, right? They will also explode in size if you're changing from 32 or 64 byte elliptic curve signatures into 3 to 8 kilobyte MLDSA signatures. That's pretty big difference, and that's per transaction.
Yeah, so that's going to grow considerably. So yeah, I guess looking at being PQC ready with the sides, that's really TLS 1.3 you really need to be to get there. And then looking at the C-BOMs is another very important aspect of this too, of knowing what you've got left to migrate to get there, and some other nuances that we're going to deal with in the industry, like OAuth and crypto.
Dig into your different use cases and really research all the different places where you use asymmetric cryptography, because it's probably in more places than you think.
Wow. All right. Well, that's a fun one. So there you go, guys. Some interesting topics to think about from here, and we'll see you on the next episode. Take care.